Lesson 8-6 Slope. And in this lesson, you learn to find the slope of a line. And it is important because when deciding a wheelchair accessible area, you need to know the principles behind slope. So, in many buildings, the wheelchair ramps are built next to the walls with stairways in the middle. If you were to compare the handrail on the ramp to the handrail on the stairway, you would notice that the handrail on the ramp is not as steep as the one for the stairs. Okay, the steepness of the handrails depends on the vertical change and horizontal change. It can be also expressed as a ratio. So when you talk about the handrail, it's basically saying this. So if this is your handrail right there, this one right there is your handrail. Okay, the steepness of that handrail will be the ratio of the vertical change, which is this one, over the horizontal change, which is that one. Okay, so in mathematics, the slope or lowercase m of a line describes its steepness. The vertical change is called the change in y, and the horizontal change is called the change in x. Okay, so the slope of a line is equal to lowercase m change in y over change in x. So let's take a look at the example 1 and see how this works. Find the slope of a line graph below. Okay, so if you notice in quadrant 1, the change in y is 4 and the corresponding change is 5. How do we know that? This is how. We'll make this small right there. Okay, and make this red so we can see it. Okay, so the corresponding quadrant 1, the change in y is 4. Okay, and the corresponding change in x is 5. Okay, to be able to get the change in y over change in x, we need to create a right triangle in this case. Okay, so if you notice, if I do this right here, let me make my straight line. This basically creates my right triangle. Oops, let me do that again. Not straight. So if I make my right triangle here, okay, that's my right triangle. Let me get rid of that. Okay, and this is how I find my change in y. Change in y would be then, see if my line stuck up here, let me get red. Okay, would be this. So 1, 2, 3, 4, 5. That's why the change in x is 5. Okay, and the change in y is 4. 1, 2, 3, 4. Okay, so this is my change in y, which is 5, 4, sorry, and the change in x is 5. So therefore, the slope of this line is 4 over 5. Okay, so is the slope of the line the same in quadrant 3? Now, if you look at quadrant 3, 1, 2, 3, this is quadrant 1, quadrant 2, and quadrant 3, and we do the same thing. Okay, and let's use this same principle. One thing you need to know is every time you go to the right, okay, every time you move to the right, do that again. Every time you move to the right or go up, okay, that is a positive change. Every time you move to the left or you go down, that is a negative change. So if you notice, we move to the right, that's a positive change, and we moved up, that's a positive change as well. And since we are talking about change in y over change in x, the slope of this line is 4 over 5. And let's use another right triangle. Let's say we have start from this point again, and we move to the left. 1, 2, 3, 4. Let me redo that. Okay, let me use this. Okay, so 1, 2, 3, 4, 5. That's a negative 5 change because we move to the left. Okay, 1, 2, 3, 4. That's our right triangle right here. Okay, and that's a negative 4 change because we move down. Okay, the slope of this line would be, okay, negative, okay, 4 over 5, or 4 over negative 5, and this is 4 over 5. And if you notice, negative 4 over negative 5 is the same as 4 over 5. So it's the same thing. Change in y is negative 4 over negative 5. It will be the same as 4 over 5. Okay? So let's take a look at example number 2. But before we do that, the slope of a line can be determined by using the coordinates of any 2 points on the line. The change in y can be found by subtracting the y coordinates. Likewise, the change in x can be found by subtracting the corresponding x coordinates. So the slope of a line, or lowercase m, is equal to change in y over change in x. Okay? Or the differences in the y coordinates over the differences in the x coordinates. But I will give you, okay, this point, a formula which is not in the book, so you copy this down. So the slope, which is lowercase m, will be equal to y sub 2 minus y sub 1 all over x sub 2. Why am I writing poorly? X sub 2 minus x sub 1. So that is the formula for slope. And let's take a look at example number 2 and see how this works. Find the slope of a line that contains point A, negative 2, 5, and point B, 4, negative 5. Then graph the line. So again, first things first, label your points. Let's label negative 2 as x sub 1 and label 5 as y sub 1. Label 4 as x sub 2 and label negative 5 as y sub 2. And if we follow the formula for slope, which is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, and we substitute the values. Y sub 2 is negative 5 minus y sub 1, which is 5, all over x sub 2, which is 4, minus x sub 1, which is negative 2. Okay, that will be our slope. If you notice, that would be the same thing. Okay, like the one that we have here, which is 5 minus negative 5. Okay, all over negative 2 minus negative 4. Okay, if you notice in this case, okay, the x sub 1 is 4, the x sub 2 is negative 2, the y sub 1 is negative 5, the y sub 2 is 5, so it's just inverted. Okay, we'll still come up with the same one. If I continue solving this and simplifying this, will be negative 10 all over 6, positive 6, or that'll be negative 5, okay, over 3. That would be the slope of this line. And if we simplify this, if you notice, it'll be the same thing. It'll still be negative 5 or negative 3. What does this prove? It simply proves that it doesn't matter what point you use as your x sub 1, y sub 1, x sub 2, y sub 2. Okay, you'll still end up with the same slope. Okay, and it says there, then graph the line. So to be able to graph that line, we need to find negative 2. Okay, sorry. Graph negative 2, 5, and 5, 4, negative 5. Okay, and our slope, after graphing it, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down. That's why you have negative 10. And then you count 1, 2, 3, 4, 5, 6 going to the right, which is a positive 6. So the way I did it is that I counted down, which is negative 10. and I counted to the right, which is positive 6, which gives me negative 10 over 6, or the same as negative 5 over 3. Okay, so in this case, okay, the book counted from the left, that's why it became negative 6, and it counted up, that's why it became positive 10. Okay? Graph the 2 points, the slope is negative 5 over 3. Graph the 2 points and draw the line. Okay? Basically, use the slope to check your graph by selecting any point on the line and then go down 5 units, okay, and 3 units. This point should be on the line as well. Okay, and that's how you use the formula of slope, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Write that down for your reference. And sometimes the vertical change is referred to as the rise and horizontal change is referred to as the run. So you can remember slope as rise over run. Okay, and we can see this in example number 3. Signs indicating the slope of an uphill are often posted in hilly areas. Find the slope of a road that increases 633.6 feet in 2 miles. Okay, so we go back to our slope, which is rise over run, which is equal to the vertical change over horizontal change. And since 1 mile equals 5,280 feet, okay, 2 miles equals 10,560 feet. And that's the reason why we converted this into feet, because we have a road that increases 633 feet in 2 miles. The units should be the same for us to be able to find the slope of this particular road. Okay, so our slope is rise over run, 633.60 over 10,560. Okay, the slope is equal to 3 over 50. So the slope of a road is 3 over 50. This means that the road rises 3 feet vertically for every 50 feet traveled horizontally. Okay, that's what it means when it says the slope of a road is 3 over 50. It means that it rises 3 feet vertically for every 50 feet traveled horizontally. Okay, and let's take a look at this example. Connection to geometry. The figure at the right shows the graphs of 2 lines that will never intersect. These lines are parallel lines. Is there a special relationship between the slope of parallel lines? Well, let's find out. So the slope of line CD would be, again, using the formula, lowercase m is equal to, well, no, let's not write that because there's an answer to that underneath. We'll write it here. So the slope of a line is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay? So is there a special relationship between the slopes of a line? In finding the slope of line CD, this is point line CD right here. And if you notice, let me make my line thinner, it'll be easier, and make it green. Okay, point C is 1, 3. So point C is 1, 3. Why is that still thick? Here you go. And point D is negative 1 and negative 3. Okay, so point D is negative 1, negative 3. Point C is 1 and 3. Okay, and let's use point C as x sub 1, y sub 1. So we label this as x sub 1. We label this as y sub 1. And we label this as x sub 2. Label this as y sub 2. Okay? You know what? Let's just use the book's version of it so it'll be easier for you to follow. Okay? So let's use the bottom part. Okay? We label this as x sub 1 and label this as y sub 1. Label this as x sub 1. Label this as y sub 2. Sorry, x sub 2, y sub 2. So if you follow the formula, y sub 2 minus y sub 1 will be 3 minus negative 3. And x sub 2 minus x sub 1 will be 1 minus negative 1. We'll end up with a slope of 3. That's line CD. And we do the same thing for line EF and find the points. And if you notice, after getting the two coordinates and following the formula, we end up with a slope of 3. Okay, so what do we notice? That when you're talking about parallel lines, the slopes are equal. Okay, so all parallel lines will have slopes that are always equal. Okay, now question is, think about it, why is the slope of a horizontal line 0? Why does a vertical line have no slope? Okay, think about this. So when you're talking about x sub 2, y sub 2, well, what happened to this one? X sub 1. Okay, when you're talking about the formula for slope y sub 2 minus y sub 1 over x sub 2 minus x sub 1, why is the slope of a horizontal line 0? The slope of a horizontal line is 0 because when you subtract y sub 2, the difference in x will be equal to 0. So in a horizontal line, okay, your change in y would be 0, and you will still have a change in x. And when you divide 0 by any number, the result will always be 0, and that's the reason why you have a slope of 0 for a horizontal line. Okay, in the same manner for a vertical line, what's going to happen is that your change in x will be 0. So for a vertical line, let's put it here. Okay, you'll have now a change in y, but your denominator would be 0. And remember our first commandment in math, thou shalt not divide by 0, and therefore the number would be undefined, and therefore that's the reason why it does not have a slope. And this is the answer right here. If it shows itself, well, I'm going to show it. There you go. All y coordinates are all the same, all the x coordinates are the same, so slope denominator is 0. Okay, let's really answer that question. Okay, but this is the correct answer right here. So in the horizontal line, okay, your change in y would be 0, and that's the reason why your slope is 0. In a vertical line, your change in x would be 0, and you cannot divide a number by 0, and that's the reason why it will have an undefined slope, or simply there is no slope. Okay, and the secret word for today would be thrashing. The secret word would be thrashing. And thank you for watching.